Assalamu alaikum students, hope you will be fine, and today our lecture is physical properties of liquid. What are the properties? The most obvious physical properties of liquid are its retention of volume and its conformation to the shape of its container. Where a liquid substance is poured into the vessel, it takes the shape of vessel, and as long as the substance stay in the liquid state, it will remain inside the vessel. Furthermore, when a liquid is poured from one vessel to another, it retains its volume as long as there is no vaporization or change in temperature, but not in shape. The properties serve as a convenience criteria for distinguish the liquid state from the solid and gaseous state. Gaseous, for example, expand to fill their container so that volume they occupy is the same as that of the container. Solid retain both the shapes and volume were removed from the one container to another. Liquid may be divided into two general categories, pure liquid and liquid mixture. On the earth, water is the most abundant liquid, although much of the water with which organisms come into contact is in not pure form but in the mixture in which various substances are dissolved. Such mixture include those fluids essential to life, blood, for example, beverage and sweat. Seawater. Seawater is a liquid mixture in which a variety of salts have been dissolved in water. Even though is pure from this salt or a solid in occasion, they are part of the liquid phase. This liquid mixture contains substances that in their pure form may dissolve be liquid, solid, or even gases. The liquid state sometimes is described simply as a state that occurs between the two solid and gaseous state. And for simple molecule, the distinction is unambiguous. However, clear distinction between the liquid, gaseous, and solid state hold only one for those substances whose molecules are composed of a small number of atoms. When the number exceeds about 20, the liquid may often be cooled below the true melting point to form gases, which has many of the mechanical properties of a solid but lack crystalline order. If the number of atoms in the molecule exceed about 100 to 200, the classification into the solid, liquid, and gas is full to be useful. At low temperature, such substances are usually gases are amorphous solid and their rigidity falls with the increasing the temperature. They do not have fixed melting points. Some may, however, form true liquid with these larger molecules. The gaseous state is not attainable because they decompose chemically before the temperature is high enough for the liquid to evaporate. Synthetic and natural high polymers, nylon or rubber, behave in this way. If the molecule are larger, rigid, and either rough, planar, or linear as its cholesterol accelerate RP exoxynolyls, the solid may melt to an anisotropic liquid one that is not uniform in all directions, in which the molecules are free to move about but have great difficulty in rotating. Such a state is called liquid crystal, and the anisotropy produce change of the refractive index with the direction of incident light and hence lead the unusual optical effect. Liquid crystal have found widespread application in the temperature sensing device and in display for watches and calculating. However, no inorganic compound and only about 5% of the non-organic compound form the liquid crystal. The theory of normal liquid is therefore predominant their theory of behavior of substance consisting of simple molecules. A liquid leak both a strong spatial order of solids through it has either density of solid and the absence of order of gas that result from the low density gases molecule and relatively free of each other influence. The combination of high density and partial order in liquid has led the difficulty in developing quantities acceptable at the theory of liquid. Understanding the liquid state as for all state of matter come with the kinetic molecule theory, which stated that matter consisted of particles in constant motion and this motion was manifestation and thermal energy. This greater the thermal energy of the particle, the faster its move. So this was our topic. Hope you understand. And friends, please subscribe our YouTube channel and like our video. Goodbye.